Okay, my name is Alan Mugenyi, and we're going to look at some code here. Yeah, we're going to implement the prototypes of a linked list, and then to start with, this is our code. The first part of our code includes the libraries, as you can see, include standard input output .h. Okay, and then we have the hash include the standard lib.h. So to start with, we're actually creating a structure node. As you can see here, we're creating a structure node, and then the structure node we are giving it parameters, which is a number, and that number should be an integer. And then we have a structure node within the same structure, and then we have a pointer next that is pointing to the structure node. And then some of the functions and prototypes you have to implement in this code. We're going to look at creating a new node where we're going to be supplying an integer, which is a number, and then we're having print list, we have append, prepend, and then deleting. And all of these we are going to look at them as we're going to see. So to begin with, I can say let's begin with how to create a new node. Okay. Creating a new node, I should tell you, let me make it a little larger here. Okay, to create a new node, as you can see, function to create a new node, we are having a pointer which is create node, and then it is pointing to the structure node, and then we are giving it a number. It should be an integer, and that's a parameter. And then as we are creating the new node, we must allocate memory, and then that's why we're using the malloc function. We are allocating memory that is going to cater for the structure node. Okay, we have an if statement here. If the new node is equal to null, then we are going to print memory allocation failed. This simply means if at all there's nothing in the new node, then do not reserve memory for that node. Since when we're creating the node, we must supply a number or an integer, because a node must contain something. So if we find out that the new node is null, then we are going to have an error statement that says memory allocation failed. Then of course we shall have to exit. This is the whole structure of the function to create a new node. And then we can see that the new node is equal to the new node. When we access whatever is inside the new node, then we see we shall supply something. We shall supply a number. Okay. Then the new node, a node specifically has a number because we're supplying a number. When you go back to the whole structure of the node, as we can see at first, in the structure of the node here, where you see my cursor, in the structure of node, we gave it a number, and also we had a pointer that is pointing to a structure node. So to maintain the structure, that's why we are making the next to be a null, because next was our pointer. So here we shall return a new node, because this is for creating a new node. So you may wonder how we're going to apply all these things. Maybe to give you a brief view before I explain all this, we can look at looking at this. If I try to build here, okay, just a compiler, it's compiling. A moment, please. Okay, so you see, you have we want to make something like this. We want us to have options where a layman can choose to print list, to append, prepend, delete by value, or to exit. So I want to make sure, because we know append, we are putting a value at the end of the linked list. Then prepend, we are putting a value to the start of the list. Then delete by value, of course, we are putting in the value we want to delete, and 5 we are exiting. So how do we implement this? A simple way of implementing this could be, let me take this off. A simple way of implementing this, we come to our main function in the code. In the code, we see we have int main, and whatever part we need to implement, whatever prototype we need to implement, should be in the int main. So you see we have the structure node, we have a pointer pointing to head. Okay, a pointer here that is pointing to the structure node, and it is null. We are making it null. Okay, we are assigning a value null. Then here we are going to want to create something which you've seen in the interface, whereby user can search, can select if something to apply. For example, one can print the list, append, prepend, or delete by value, as you've seen. So we're going to use something we call a switch. A switch helps us alternate between the choices. If you want to print the list, of course the switch will say, now execute this. If you want to delete by value, of course the switch will take you to delete the value. Now, to go back, how do we achieve this? These are all cases, case 1, case 2, 3, 4, and 5, as you've seen. So we go back to the functions. I'll take you through the append and prepend functions. As we see here, we've seen how to create the new node. Then we see how to print the linked list. Okay, printing the linked list, we are seeing a void print list, our function. Then it is taking in one parameter, which is a pointer head that is pointing to the structure node. Now, structure node, we are initializing a temporary pointer. We're using a temporary pointer that is called current, that is also pointing to the structure node, and we are giving it head. Okay. Then you see we have printf. Then we open the bracket, the first bracket for the list. Then we are using the while loop. So while current is not equal to null, if we are going through the nodes, as we are traversing through the nodes in the linked list, we must see if we find when the current node is equal to null, then of course we are not going to print anything, because at the moment we shall not be having anything. But if it is not equal to null, then of course we shall go on with the while loop and then print whatever is inside the node. So to continue to the append, append is taking in two parameters, which one is the number, which should be an integer, and a double pointer here that is pointing to the structure node. And then we have a pointer new node that is pointing to the structure node. And then we are creating a new node and we are assigning it num. So here, since we are appending, we are checking if the pointer head is equal to null, then of course the new pointer head is going to become our new node. Okay, because we want to append, then we are using the else structure node. Then you see a pointer current, our temporary pointer that is pointing to structure node, and then we are going to assign it to a pointer head. Then we say while current, because you have this arrow that has a greater than sign, this simply means you are accessing the members within the node. And then maybe something we can say here. Okay, as we're still looking at this, we are seeing here we are accessing members inside the node. So we can look at this maybe. This is simply the appending. Then prepend is more like the appending part. So it is, we are having two parameters, one with a number, and then we have a double pointer head that is pointing to the structure node. Then we have a new node, the pointer, a new node is now a pointer that is pointing to structure node, and then we're using it to create a node and we are supplying it with a parameter num. Then here, since we have the new node and we are accessing the next, then we are assigning it to the pointer head. And now the pointer head is going to become our new node. Simply we are creating a new node. That's why we have a double pointer. Then to delete, of course deleting, we are going to look at it here. Now maybe to simply try out the program, you can see here, if you are to print the list, if I'm to append to a list, okay, printing the list here, I choose 1. Then of course they are printing for me an empty list. And then if at all I'm to append to that list, I'll press 2. Okay, then I will append a number, for example 45. Okay, if I want to print that list, then I press 1. Now if I want to maybe prepend, I want to put before, then I choose option 3. Then prepending 78. Okay, if I want to print my list, then of course 1, and then my new list has 78 and 45. Now if I want to delete something